In the previous video, I mentioned that if you start off with a cosine graph, which is this red line here, if you start off with your cosine graph, let's say your cosine graph is here. If you shift it across by 90, if you start off with a cosine graph and if you shift it across by 90, you will in effect have yourself a sine graph. It will be an exact same as a sine graph. Okay, and in this video we're going to try and understand why. So let's look at let's look at this circle here of radius 1. So we've got a circle of radius 1. So that means the hypotenuse here is 1. Now let's enlarge this triangle here. Okay, let's enlarge the triangle. So it's like this. Hang on. So here we've got a triangle here. At an angle, this here is 90 degrees. This here, it could be any angle. Let's just say it's theta. So this triangle here is this triangle here. Okay. Well, if this angle here is theta, then this angle here is 90 take away theta. And the reason for that is no matter what triangle you have, all the angles inside add up to 180. Okay, well, if this angle here is theta, well, all the angles add up to 180. So if you take away this angle here, so take away 90, and then take away this angle here, which is theta here, then what's left will be this angle here. So single number, you can merge these two together. So that will be 90, and then take away theta here. So this angle, this 90 take away theta is this angle here. So that's this angle here. Okay, so if this is theta, then this must be 90 take away theta. Okay, now this circle is of radius 1. So that means the hypotenuse here is 1. So that means that this distance here, the hypotenuse here, is 1. Now remember, if the sine of theta represents a height. Okay, let's just call it y. You want to know what y is. So using this as a reference point here, this here would be opposite, adjacent, and hypotenuse over here. Now, if you want to know the height here, which is, well, if you want to know the height here, it would be sine theta. Okay, because we've got to use sine here. We've got to use sine here. Okay, so sine theta equals y, which is the opposite here, divided by the hypotenuse, which is 1. See, y divided by 1 is just y. So sine theta equals y. Okay, so sine theta is really the height here. Now, rather than using this as a reference point, use this angle here as a reference point. Hang on, let me tidy this up. So here we've got a triangle here. This angle here is theta. This one here is 90 take away theta. And we've established that when we use this as a reference point here, the height here is really sine theta. Okay, so sine theta here represents this height here. Now, rather than using this as a reference point, use this as a reference point. So really, you're using the technique of trigonometry that I taught you. The sea is here, the sun is here. So really, this is your opposite, your adjacent, and your hypotenuse, which happens to be 1, by the way, because the distance here is 1. Okay. Well, and anyway, rather than using this as a reference point, we are going to use this angle here, 90 take away theta, as a reference point. So in which case we're going to need cos. Okay. So now because we are using this angle here as a reference point, then this here is your adjacent. So it would be so if you want to know this height here, let's just call it y. Okay, so it will be well, remember, we are using this angle here as a reference point, so it will be cos of the angle, which is 90 take away theta here. Okay, equals y, and then the hypotenuse here is 1, which is just y, which is just y. Hang on, which is just y. You see, when we use this as a reference point, this length here is given by sine theta. Now, when we use this as a reference point, then y is given by this here. So you know that sine theta is is the same as cos 90 take away theta. Okay, this doesn't fully explain it, but it's a nudge in the right direction. You know there's some sort of relationship going on here. So yeah, so remember from our transformation, when you, well, anyway, yeah, just bear in mind that this doesn't actually fully explain it, but it is a nudge in the right direction. There is some sort of relationship when you can see that here sine theta is the same as cos 90 take away theta. It doesn't fully explain it, but it's a nudge in the right direction. Okay.